All right, so I'm going to get started here. First of all, thank you folks for coming for the session. We are going to be talking about virtual SAN or vSAN. My name is Vijay, right here, and I am in the product management team, storage product management team at VMware. And Christos Karmanalis, who is my colleague, he is the vSAN architect who helped develop vSAN. And the goal for today is to dig a little deeper, go under the covers, and talk about how vSAN works. And before we go into the details, I will kick off this session by providing some context and giving you, providing an overview of what our vision is, what VMware's vision is around storage, and also give you a high-level overview of what vSAN is, and then hand it over to Christos to talk about how vSAN works under the covers. Okay, and towards the end, we'll talk about some of the use cases, beta, what you need to do for beta, and we'll probably have some time towards the end for Q&A as well. Okay, so with that, let me get started. VMware's goal in storage, or VMware's goal in general, is to enable the software-defined data center. And the idea behind software-defined data center is to virtualize all infrastructure components in your data center. And by virtualizing all the infrastructure components such as network, storage, and compute, we provide a way to simplify the provisioning of these services and also greatly simplify or greatly increase the operational efficiency of your data center. Storage is an important component of the software-defined data center, and so the goal behind software-defined storage, which is a component of software-defined data center, is to be able to abstract and pool any storage that's connected to your vSphere, be it local storage, be it external storage. No matter what storage you have, you want to be able to abstract out the storage from the physical hardware, pool them together, and provide logical pools to carve out storage for your applications. And the second goal of software-defined storage is to be able to then manage these pools of storage in an app-centric way and provide SLA management in an automated manner. So software-defined storage, just to summarize, is all about abstracting out storage resources from the hardware, pulling them together, and providing an easy way for you to provision storage from these logical pools, and provide a way to enable automated SLA management on a per application or per VM basis. And what you'll see with vSAN, as Christos goes through vSAN, is how we do it for local storage. So vSAN is VMware's first foray into realizing the vision of software-defined storage. And the main components of VMware software-defined storage is three components. The first component is a virtualized data plane, which allows you to abstract and pool external storage, shared storage, or direct-attached storage. So the first component of software-defined storage is virtualized. It's a virtualized data plane which allows you to abstract and pool storage, either direct or shared. And as you'll see, vSAN falls in this category, direct-attached storage. The second component of software-defined storage is data services, and we want those data services to be applied on a per VM granularity or per VM basis. And the important point to note about data services is that the invocation of these data services can be from anywhere. So the invocation can be, the execution of those data services can be done on a shared storage system, it can be done on a direct attached system such as vSAN. But the important point is that we want to be able to manage the automation of execution of these data services, and that's where the policy-driven control plane comes into the picture. So the third component of software-defined storage is policy-driven control plane, which automates the SLA management across shared storage and local storage. So those are the three components, and as you'll see in vSAN, all of these three components are applied in vSAN for a model where we utilize locally attached or ESX attached storage devices. Okay. So with that, let me just give an introduction of vSAN before handing it over to Christos. What is vSAN? vSAN is a scale-out storage system that's built into the hypervisor. And the idea of vSAN is to take ESX-attached storage devices, hard drives and SSDs, cluster them together and provide a shared pool of storage to provide a pool of storage to store VMs on. And this pool of storage that we deliver to store VMs on, although it's made up of local disks, it looks and feels like a shared storage system. So it exhibits all the behavior of a shared storage system. So features such as DRS, vMotion, SVMotion, everything works exactly the same way as it does with an external storage system, except in the case of vSAN, it's all local disks. The third component of vSAN is that it uses it's flash optimized, so it uses flash both as a read cache and a write buffer, as you'll see. And the kicker with vSAN, or the big value that we want to provide with vSAN, is in its management. So as I said, one of our big push towards enabling the software-defined storage vision is a policy-driven control plane. And what we have done with vSAN is deliver a model or an approach where storage management is completely automated. So with vSAN, as you'll see, we've taken the approach of a policy-driven storage management, where when a VM is provisioned on vSAN, you apply specific policies to the VM, and vSAN under the covers, vSAN as a system under the covers, will ensure that the policy is always met throughout the life cycle of the VM in an automated manner. Just some of the salient features of vSAN. I won't go through this too much because you'll see a lot of this in Christos' section. vSAN is a scale-out storage system. So what that means is that both performance and capacity scales linearly as you add more nodes. So a vSAN node, is designed to scale from 3 nodes to the size of a vSphere cluster. And so as you add more nodes to a vSAN cluster, your performance and your capacity scales linearly. I already mentioned this, but although vSAN is made up of, provides a shared pool of storage to store VMs on, it's made up of local disks. So all the properties of a shared storage system applies to vSAN as well. I just want to point out one last thing about vSAN. vSAN, as you would expect from any enterprise storage system, vSAN is highly resilient. So there are no single points of failures, and we've also implemented a distributed RAID mechanism for resiliency. So vSAN can protect against component failures, node failures, and so on. And you'll see how shortly. All right, so that's just an introduction to vSAN. I'm going to hand it over to Christos now to talk about how vSAN works under the covers.
Thanks, Vijay. Can you hear me? Great. Okay. So in this section of the presentation, I'll go into some of the technology behind vSAN. And I will start with giving the basic architectural principles behind vSAN. This is a distributed layer of software that runs as part of the hypervisor on every ESX host. It aggregates the local or direct attached storage, both flash, PCIe and SSD, as well as magnetic disks, and makes all that storage, as Vijay said, appear like a shared pool of storage, shared across all the ESX hosts. So in other words, it provides a converged compute storage infrastructure where you have ESX hosts, where your VMs run as usual, while at the same time a small slice of CPU and memory from every single of those ESX hosts is used to serve the data, the storage needs of your VMs, your applications. So vSAN, how do we manage and configure this shared storage? we made the decision to make vSAN a property of vSphere cluster. There is no inherent requirement from an architectural point of view, but this decision makes management and integration with other vSphere solutions much easier. So, for example, to enable vSAN, it is as simple as going to the management pane of vSphere cluster in the UI and click a radio button. That's it. Automatically, in that case, vSAN is going to claim all the available local devices, flash and magnetic disks, on those ESX hosts that are on the cluster. By automatically claim, I mean if a device has no other known partition, we're going to grab it and use it for vSAN. Alternatively, the administrator may decide to go and cherry pick the specific devices on every single host that they want to use for vSAN. And all this setup and configuration can be done when you are initially creating a vSphere cluster or later on an existing cluster. vSAN may dynamically grow by either adding hosts to a cluster or adding more storage devices to existing hosts. So as you can imagine now, your storage needs may grow in tandem as your compute infrastructure grows and as the demands of your applications and your VMs, so the numbers of VMs that run on the cluster grow. So this is the idea that you don't need to do like big provisioning, big purchases of storage in order to, as an entire disk array or big chunks of storage, as is typically the example with external storage. Things grow in a finer granularity as your compute infrastructure also grows. Now, don't think that all hosts have to be identical. There is no such requirement. In fact, we may even have hosts that participate in the cluster and share this virtual common pool of storage without even having any local disks themselves. However, as a good practice, we recommend that the hosts are more or less well balanced in terms of the storage resources they provide. That means we have more options for availability, better overall resource utilization, and therefore better performance. The key idea here is that this pool of storage, which consists of all those local devices, appears to the ESX host in the cluster as one data store, a single data store that is accessed by all the hosts in the cluster. This is for all practical purposes the same as a VMFS or an NFS data store and supports all the vSphere solutions that assume a shared storage. The capacity of that data store is determined by the aggregate capacities of the magnetic disks that are used in vSAN across all the hosts. So as we add magnetic disks to the existing hosts, the capacity of that data store grows. All right? vSAN stores all the data eventually on magnetic disks. All the writes you make, all the writes that go from the VM and application down to the storage eventually make it on the write disk. And I'll explain how we use actually flash as a write buffer. So what we do is we take advantage of the fact that capacity of magnetic disks, especially those local devices, whether SAS or even more so SATA drives, the capacity is very cheap. Really, it's below 10 cents per gigabyte these days. So capacity is very cheap. So what we do is we use redundancy aggressively to meet the availability and reliability requirements of your applications. Specifically, we do replication. We replicate data across hosts and disks in order to ensure that under any combination of failures, your data will be there and will be available and accessible by the VMs and the applications that run in them. Now, on the other hand, so the capacity of the magnetic disk has been growing fast over the years, and the cost of that capacity, as I just said, is going down. On the other hand, the performance of those magnetic disks has not caught up with that trend. Magnetic disks actually do decently provide decent bandwidth for sequential workloads. but they have a couple of major problems. First of all, they do pretty bad for random workloads. And as you know, most workloads are random, especially in virtualized environments where you have hundreds or even thousands of VMs sharing storage. The workload that goes to the storage is actually random. Also, magnetic disks do very badly with operations per second. You pay several $100s for a couple of terabytes of disk, and what do you get out of that? 100, perhaps up to 200 IOs per second. So if you think from a kind of cost, you pay several dollars for an IO per second for a magnetic disk. Those IOPS are very expensive and very valuable magnetic disks. On the other hand, we have flash that is becoming increasingly more common. The capacity of flash, whether SSD or PCIe, is still quite expensive, relatively speaking. We're talking about dollars per gigabyte. However, IOPS are plentiful. You buy an SSD, you pay a couple of $1,000s. That SSD gives you typically tens of thousands of operations per second. So think about that. We're talking about less than 1 cent per IO per second. $2, $3 per IO per second magnetic disks, 1 cent per IO per second for flash. So what do we do in vSAN is we take advantage of flash for getting the performance of your workloads. So we use the flash both for read caching as well as write back buffering. So at a high level, we combine the best of two worlds. We use aggressively the very cheap capacity of the magnetic disk to get you reliability and availability for the data. And we use the very cheap IOs per second from the flash to get the performance. IOPS, throughput, and actually low latencies from flash. So let's see now how we provision virtual machines on this new type of storage, on vSAN. When the user creates a VM, when they provision a VM, they specify a set of policies for this specific VM. Those policies capture quality of service properties, such as thick or thin provisioning, and anything in between. They capture availability properties. I want to be able to tolerate up to 2 failures, whether those are host, disk, or network failures. And we interpret those things into number of replicas we create in the system. Or performance policies, such as reservations for flash, or perhaps even the number of stripes you want to have for each replica, if there is a need to spread a replica across multiple spindles of magnetic disks. So the key idea here is that you specify those policies for every single virtual machine and every single virtual disk, according to the needs of your application that runs in that VM. Now, and those are provisions, and the vSAN provisions those individual VMs and VMDKs with those policies, and as we'll discuss in a few minutes, monitors and enforces those policies automatically. Now, you tell me, if I have thousands of VMs to provision, do I have to specify those, a list of policies for every single one of them? No, this is not very scalable. So what we have done is we're provisioning a wizard through which you can go, somebody, typically an administrator that is aware about storage properties and the workload characteristics of applications. That administrator goes and creates a number of templates. We call them policy profiles, storage policy profiles, that capture a set of those policies that are applicable for a certain application, for certain classes of VMs, and gives them names like gold or silver, or perhaps engineering workstation storage profile. So now a user and another administrator goes and provisions VMs, can go and choose one of those pre-specified profiles and provision the VM without having to worry anything about specifics of storage or having to understand workload characteristics or anything like that. We provide strong integration of these policy profiles with the UI, and also expose them through the Vsphare API, so you can use them for in a programmatic way for VM provisioning. Let's see now what exactly I mean by we are provisioning individual VMs and VMDKs with their own policies. When we create a VM in vSAN, we create for that VM a number of objects. Think about an object as a little virtual volume, logical volume. We create one object within which we put all the metadata of the VM, files like config, log files, descriptors, things like that. And also, we create one object for each of the VMDKs. So let's take the example of this blue virtual disk here in this figure. When we provision that virtual disk, the object for that virtual disk in vSAN, we look into, on one hand, what are the policies that the user specified, availability, performance, type of provisioning, capacity provisioning. And on the other hand, we also see what are the resources in the cluster, available capacity, available performance on the flash devices, on the magnetic disk, on the host. And based on those two types of criteria, we decide how, first of all, to replicate the object. In this case, we create two replicas. Where to place them, on what magnetic disk, on which host, what flash device to use for caching, and the flash is always the flash in front of the magnetic disk on the same host. So what flash to use for read caching and for write buffering for each of those replicas. So on overall, vSAN is load balancing and optimizes the use of the resources in your system, so you don't end up with a host having all its capacity, magnetic disk capacity, filled while it is completely underutilizing its flash, or vice versa. You utilize your flash approximately the same way you utilize capacity in the magnetic disk and so on. Here's an example of how a specific virtual machine, actually a virtual disk of a virtual machine, is replicated in the system. As you see here, let me see if I can point. This virtual disk here, hard disk 1, has two replicas. We have a RAID 1, synchronous replicas, and has two replicas on two different hosts, on different disks, of course. As you see here, we also have, there is a thing called witness. Witness is a dummy type of replica, which contains only metadata, no data. We use it in order to make sure that in the case of potential network partitioning, we will not end up with a split brain situation. So depending on what side of the partition that witness is, it will create quorum, majority, with at least one of the replicas. So the data and the VM are still accessible in that partition. So through this UI and through APIs we provide, one can figure out exactly how their VMDKs are distributed in the system, can go and see the state of those VMs and those VMDKs and how they are doing, and talk more about that. But before we go into actual monitoring and enforcement of policies, I want to explain, now that you know how things are distributed, explain a little bit how I/O works, how writes and reads work in vSAN. And let's start with writes. When the guest operating system in a VM performs a write operation on a virtual SCSI disk, that operation goes to the local module of vSAN on the same host where the VM is running. There, vSAN knows what replicas that virtual disk has, and in parallel, sends the two copies of the writes to the two replicas. And at least one replica is going to be remote, or both of them may be remote. So the writes go to the other hosts, and then vSAN performs those writes on the flash, on the write buffer, on the flash device that is in front of the magnetic disk where each of those replicas resides. As soon as the writes make it on all the flash devices of the replicas, then we can acknowledge that the write is complete back to the guest operating system. That means, in other words, that from the moment a write completes to the guest operating system, we guarantee you that we have as many writes, sufficient redundancy as has been requested by the policy that the user specified. So you see there the data is on the right buffer on the flash, and later on, vSAN will retire that data to the magnetic disk, where the actual long-term storage of the virtual disk is. When that will happen is a matter of internal algorithms that are used by vSAN. It could be seconds later, or it could be even many minutes later. vSAN is optimizing many things. You understand, if those written data, the dirty data, stay in the right buffer in the SSD, more overrides of the same data may come from the guest operating system. If we retire the data 5 minutes later, we're going to retire only one copy of the data, not the 100 different overrides that happen to the same data. Another optimization that vSAN performs is that we retire from the flash to the magnetic disk data in batches. And those batches are actually data that are in physical proximity on the magnetic disk. So essentially, we write the data from magnetic disk using a sequential workload. So we use the last, squeeze out the last bit of performance out of those magnetic disks. That bandwidth magnetic disk is really valuable, so we really optimize how we utilize it. Let's see now how reads are performed. Again, when the guest operating system, the VM, performs a read operation to the virtual disk, it goes to the vSAN module on the local node, and vSAN now will decide which replica to read the data from. Picks one replica and sends the read request to the host where that replica lives. That may be another host or could be local. In this example, it is another host. In the vast majority of the cases, vSAN reads the data from the read cache on the flash really fast, when the data happens to be part of the active data set of the application that resides in the read cache in the flash. If, in some unfortunate cases, very few percentages of that data is still on the magnetic disk, we bring the data from the magnetic disk to the flash, we serve it, we return it back to the virtual machine, and we keep the data in the flash for potential future accesses. Now, one thing to notice here is that vSAN actually, again, is clever. It tries to load balance which replica it sends read operations. However, we always send reads for certain logical block ranges for a virtual disk to the same replica. Why we do that? Because we want a certain block to be in the read cache of only one flash. A block is never cached in more than one flash devices, because remember, flash capacity is expensive, so we want to use it prudently. Now go back to, again, how vSAN is exposed to vSphere and other solutions. As Vijay mentioned, and as I briefly said earlier, vSAN appears as a single data store that is accessible by all the hosts in the cluster. So it works seamlessly with all vSphere solutions that require shared storage, HA, DRS, so on. Let's take the example of DRS. Here is a VM which runs on a host which is overloaded. DRS, using its own heuristics, decides that this VM has to be vMotion migrated to another host. vMotion does its job, the VM is moved to the other side, seamlessly continues running from there. It accesses again its data that is on the vSAN data store, irrespective of how and where its data are replicated at this point in time. vSAN, in the meanwhile, is always monitoring actively the state of your data for every VM decay, and automatically enforces those policies that the user specified, even if things happen in the system, like failures or degradation of performance for some devices, or even sometimes when the workload changes. So here's an example where we have a virtual disk, which actually has a replica, the blue replica it's a little small, on this host, which actually happens to be on some disk that is running out of space, because some of those, the virtual disks that happen to have replicas on the same disk kind of grow very rapidly. vSAN observes that and automatically moves that blue replica to another host and other devices, which are less loaded, has less capacity use, or perhaps less flash utilization. So not only vSAN enforces the policies the user has specified, but it's also optimizing and balancing the overall resource utilization in the cluster so that you have more capacity, more opportunities to provision more storage. And these things are not left to a human. These are problems that are hard to argue and monitor when you have, 8 or 16 or 32 hosts, and you have on each host tens of devices. It's very hard to do those things manually, right? So vSAN does all those optimizations automatically for you. But at any point in time, you know really what is happening with your VM and your VMDK. Because if for some reason vSAN cannot automatically does all that reconfiguration and enforcement, it will let you know that the VM or that specific VMDK is out of compliance. And we'll explain to you why it's out of compliance. Because I run out of magnetic capacity, or I run out of SSD IOPS, so I cannot really get the performance you want. So vSAN actually provides a whole set of tools through which you can go and really look into the system and understand what is happening in terms of the resources that are used. For example, you can go and figure out if you have, from a physical perspective, you can go and see CPU that is used, memory, like magnetic disk and flash devices utilization in terms of capacity, in terms of bandwidth or IOs per second. Or you can go and look from the perspective of a specific VM and see what resources that VM uses. And where are those resources used from? Excuse me. So the idea is that vSAN provides all those tools through which an administrator can go and figure out exactly what is happening in their system. They can answer questions such as, why my VM doesn't get the performance I was expecting? Are there any bottlenecks in the system? Are the bottlenecks in CPU? Should I go and add a couple of hosts in the cluster? Are the bottlenecks in flash? Should I add more SSDs in my system? Those kind of questions, those kind of critical, important questions that an administrator, typically a storage administrator, but now even a vSphere administrator can understand, quantify, and react to. Last but not least, vSAN is fault tolerant, the resiliency that Vijay mentioned earlier. So let's take the example. It tolerates actually host failures, the individual device failures, or network failures. Let's take the example here of a host going down. As soon as that happens, immediately HA, which as I said works seamlessly with vSAN, will kick in and restart any VMs that went down with that host to some other hosts in the cluster. Right? And assuming that the user has specified sufficient availability, those VMs will still have at least one copy of the data and will continue running. And the same with all VMs in the cluster. No VM should go down because that should be inaccessible and blocked because that host went down. Now, in the meanwhile, vSAN keeps monitoring what happens with that host. Is that a transient failure or is it a permanent failure? And if the host doesn't come back after some time, the default value is 30 minutes, vSAN says, oh, there is a permanent issue with this host, so I should start reconstructing any data that disappeared when that host went down, data that were on the disks, like replicas of VMDKs and VMs that were on the disks of that dead host. So this reconstruction is happening in the background and in parallel to the normal operation of VMs. In fact, vSAN has algorithms and scheduling mechanisms that ensure that the reconstruction traffic will be throttled back and will not affect the normal operation of the workloads in the cluster. And with this slide, I've completed this kind of technical overview of vSAN. I'll pass the floor back to Vijay, who will talk about product hardware requirements, use cases, and some performance data. I'll be happy to take answers later on, questions later on.
So Chris went over some of the technical details of vSAN. I will cover the requirements for vSAN. We announced vSAN as a public beta with VMworld San Francisco or VMworld US. How many of you are planning to try out vSAN as a beta? It's quite a few. How many of you have already tried it? Few. Okay. So what's required for vSAN? For those of you who are going to try it, it requires at least three hosts at a minimum. And the version of vSphere that you need, that vSAN is supported on, is vSphere 5.5. So you need 3 hosts that's running vSphere, at least 3 hosts that's running vSphere 5.5. Of course, you need a vCenter server, and each host that's participating in the vSAN cluster requires at least one SSD or PCIe flash card and one hard drive, magnetic disk. As far as the network connectivity between the hosts go, we will support, vSAN does support both GigE network as well as 10 gig network connection. The recommended is 10 gig. Obviously, that depends on your workload, and there are many factors that go into making the decision, but the recommended is 10 gig. But we will support both gigabit Ethernet connection as well as 10 gig. We will assume that the virtual networking is configured before vSAN is turned on or configured, and all the hosts that are participating in vSAN needs to be on the vSAN network. Okay. So as far as hardware requirements go, as I said, 10 GigE or 10 gig NIC is required on each host. vSAN requires either a SAS or SATA controller, essentially an HPA, for connecting the hard disks to the host. We will also support RAID controllers. The point to note here about RAID controllers is that it's recommended to have those RAID controllers on the server in a JBOD mode or a pass-through mode. Some of them call it pass-through mode, some of them call it JBOD mode. Essentially, vSAN consumes raw disks. So if you happen to have a RAID controller in your server that you're enabling vSAN on, ensure that that RAID controller supports pass-through mode. It's recommended that the RAID controller supports pass-through mode for optimal performance. We will support non-pass-through mode as well. However, from a performance standpoint, from optimal performance, we expect vSAN to consume raw disks. Okay. And I mentioned this before, vSAN supports SAS or SATA SSDs or PCIe flash cards, and SAS or SATA hard drives. Okay, so these are the hardware requirements for vSAN. We will have, when we with beta as well as with GA of vSAN, we will have a hardware compatibility list which will list all the components that that are compatible with with vSAN. And speaking of which, we have been working for the last few years since we've been developing vSAN. We've been working with a broad array of our partners, so that the components from these partners will be supported, can be supported on vSAN. So we have been working with them, and there are many more partners that we're working with, and we've gotten pretty good reception from our partner community ecosystem to support vSAN. All right, I want to spend a couple of minutes on the use cases that we're targeting vSAN 1.0 for, and the reason I emphasized 1.0 is because the use cases for 2.0 will be much broader, obviously. But for the first version of vSAN, we expect vSAN to be deployed in 3 different scenarios. VDI, or virtual desktop, is the first use case that we're targeting vSAN for. The second use case that we're targeting vSAN for is, we call it a tier 2, tier 3 workload. Essentially, it is test and dev type workload, and talk about each one of them in a second. And the third use case for vSAN is as a disaster recovery target, or DR target. The reason why virtual desktop is a good target for vSAN is because vSAN, as you'll see in the next couple of slides, vSAN handles essentially your performance requirements of VDI deployment, and it handles it in an efficient way while lowering your cost of your total solution. And so it's a good target for for vSAN. And I have a slide. I have an upcoming slide that shows what is the performance that we have that we can get with vSAN in a VDI deployment. Tier 2, tier 3, or test and dev type workloads are a good fit for vSAN because, again, ease of provisioning, per VMDK management, lower cost of storage. All those are good reasons why vSAN is a good fit for for test and dev. And finally, DR target. We've talked to a number of customers about vSAN, and one of the things that's come up in our conversations is that, hey, a lot of our customers have compliance requirements and so on to have a DR policy in place, and they find it extremely expensive to replicate the primary data center for the DR target. Your storage cost becomes prohibitively high, and so vSAN, because it uses local disk, is a good target. Being a DR target is a good use case for vSAN because you lower your cost of storage on your DR site. Of course, for this to happen, you need to have some kind of a host-based replication solution to replicate the data. But the cost of storage itself as a DR target is lowered with vSAN. All right. So speaking of performance, here's a chart that compares vSAN to an all-flash or all-SSD storage system for a VDI deployment. And what this chart shows is that the number of VMs that can be supported on vSAN is exactly the same as what can be supported on external storage system. So the VM density for a VDI deployment is exactly the same between an all-flash and vSAN. So across a vSphere cluster, you can deploy the same number of VMs, which speaks to the performance that vSAN can deliver for VDI. However, if you look at the cost of vSAN and compare that to the same all-SSD external storage system, vSAN comes in at 25% of the cost of an all-SSD storage system. So for VDI, the key message is similar performance compared to an all-SSD storage system at 25% of the cost. More importantly, because vSAN can scale linearly in terms of performance as well as scale, as well as capacity, as you scale your VDI deployment from, say, 500 VMs to 1,000 and above, the upfront investment with vSAN is the same. So it's small because vSAN is a much more granular unit of storage. As you scale your VDI from POC to production to 500 and beyond, the upfront investment is very small. If you compare that, it's steady. And if you compare that to an external storage system, you have to have a huge upfront investment each time you scale your VDI deployment. And this is a very important point to note, particularly for VDI deployments. All right. It's kind of cheesy, want vSAN. But vSAN is public beta. Go try it out. There's a very active vSAN community forum right now. Post your questions there. All of us are on the community. I will answer your question as soon as we see it. So participate in the vSAN community, download the beta bits, and try it out, and let us know how it goes. Okay. And I believe there's also a prize you win if you participate in the beta. All right, so just to summarize what vSAN is, scale-out storage system, built into the hypervisor. It's not a virtual appliance or anything like that. It's native to the hypervisor and architected around policies from ground up, architected around policy-based management, and per VM decay or per VM operations. And to net it out, it is an enterprise storage system that's radically simple and at a much lower price point. So there are some other sessions on vSAN. If you wish to attend best practice and so on, there's a session at 5 o'clock. But I think at this point, we have enough time to take some Q&A.
Questions? Oh yeah, there are a couple back there.
Hi, thanks. What's the impact on performance to the hosts?
Mm-hmm. All right. The question is, what is the impact in terms of performance to the host? And I assume that means CPU and memory use from vSAN itself. We have put a very strict upper bound, which is extremely conservative, that will never consume more than 10% of CPU and memory on the host. In reasonably sized clusters, like bigger clusters, where we are well below that number. If your cluster becomes smaller, and depending also on the consolidation you have on terms of VMs, we may get closer to 10%, but really, for all practical purposes, we're talking about small single digits. Yep.
How is it licensed?
That is a product question. I'll let Vijay answer.
The short answer is I cannot say anything at this point about licensing and
you needed a microphone for that?
But we're discussing various models, but at this point, it has not, the honest answer is it has not been decided yet. And we need to, as we make up this decision, we'll keep you guys posted.
So you get another reason to be on the beta forums, maybe some announcements there.
Very close to what you don't want to say. Is it going to be a solo product, or is it going to be part of vSphere? At least that you should say.
Another question over there?
Well, you've just talked about you can define the number of replicas across the cluster. I was wondering how intelligently does vSAN operate in multi-data center environments?
Mm-hmm. So the question is, what about replication across different data centers, right? So vSAN, at least in version 1, it is really focused of being a storage solution within a data center. So we have not explicitly designed for replication across data centers, and definitely not across long distances with very high latencies, where you will have probably this kind of synchronous replication model that I described here will not be applicable. There are other solutions from VMware and from partners for remote asynchronous replication. VMware solution is vSphere replication, and partners have other solutions themselves. But in version 1, we are focusing on doing replication within a data center or within latencies that are very similar to that you find within a data center. So we can probably go across buildings, but not really remote locations.
When you go across these buildings, can you specify that at least one replica is being building?
That's a good question. So the question is, if you have replicas across buildings or maybe physical racks or something like that? Can you specify that? I cannot guarantee we'll do that, but we're working on a feature where you can specify your fault domain, which could be a rack or a building or something like that. And in that case, vSAN will ensure that we'll never put two replicas in the same fault domain. Right? There was a question here.
How looks like this installation? Is this kind of driver by installation on the host, or how it works?
So, okay, the question is, what is the story about installation? And so, again, even though we cannot disclose much of the packaging, vSAN is an integral part of vSphere. So, no matter what, you won't have to go through some complex installation process to install vSAN itself. Will be through some licensing, perhaps, you'll be able to enable a feature. I don't know how much more Vijay you want to disclose on that. So it won't be like a separate product. You have to go through an entire new installation process. That's for sure.
If I would like compare normal SAN and vSAN, virtual SAN, if I install this, can you say something about performance losses?
First of all, using vSAN on your cluster does not exclude you to use any other storage system,
I mean,
SAN or
if
otherwise.
I installed after that on the same hardware, I've installed your product. Can you say 10% slower or?
Are you referring now to what? Are you referring to the other storage? Are you referring to the performance of the ESX host?
Yes, I mean, if I install, it's actually kind of buffer or kind of program that will do my hardware a little bit slower in comparing with normal SAN. How much it will be slower?
This is all a matter of what SAN you're referring to, what array, right? And what kind of interconnect you have between your system. I'll say only one thing. With vSAN, you have flash devices that are local on the host. Those flash devices, as you know, have very low latencies. And we go potentially, especially when we write, we go over the network to access the data. So there is a little bit of additional network latency there to go to your data. But that is the case with any storage system. So in principle, if I want to give you a very simple answer, I would say it all depends on the networking and the infrastructure you have, both with vSAN as well with any SAN storage. Another question out there? And we'll come to you afterwards.
Do you handle dual-hosted SAS disks, or do you plan to?
At this point, we do not support dual-hosted SAS disks. That is definitely something we're considering of doing. I cannot give you any commitment about what that will happen, but it's definitely on our agenda. And there was a question back there.
Yeah. Will vSAN replace the VSA? And the second one, what about DRS? If you move the VM around, is there an intelligence so that the VM will reside on a host with a replica, or can it do some rules like should run on a host where the replica is?
So let me start from the second one, because I'm not sure I will answer the first. So the question is, what happens do we coordinate between DRS and the placement of data by vSAN? The answer is no, and that has been done by design. DRS makes placement decisions of VMs and decisions about moving VMs based on the utilization of compute resources, CPU and memory across the cluster. vSAN makes placement decisions based mostly on the utilization of the storage resources, flash and magnetic disk. And we want to keep the two separate. In fact, we are not making any explicit attempt to have the data close to the VM, because VMs are mobile. They move, your cluster is a pool of storage, or a pool of resources. So your DRS moves VMs around. VMs are mobile. So trying to move the data, big chunk of data behind your VM is not a good idea, especially given that the latencies of contemporary networks are so low that it really makes no substantial difference in the performance you get out of your storage. And I'll be happy to talk much more about that. That's a very exciting topic offline if you wish. Now, on your first question, VSA.
Is it working? Okay. The question is whether VSA is going to be replaced by vSAN. There are no current plans to replace VSA directly with vSAN. As it stands right now, VSA is its own product. vSAN is its own thing.
And we're targeting different use cases.
Yeah, it's completely, it's different use cases. VSA is targeted for much smaller, robo-type deployments, SMB-type, SMB, small and medium business-type deployments. And vSAN is more of a data center type product. So there are no plans right now. We would expect in the future some convergence of technologies, but the only thing that I can tell you right now is that they both are independent from a product standpoint.
Perhaps last question over there.
Okay, but the question is how far will vSAN scale? So how much servers can be?
The question is what is the scalability of vSAN? So in the current public beta that's been going on, we officially support clusters of up to 8 hosts. What we're going to be supporting in GA next year is something to be determined. Inherently, there is no any scalability limitation for vSAN. Our goal is at some point to make the size of vSAN cluster to be whatever is the DRS, the vSphere cluster size. Now it's a matter of, I guess, product placement and not really technology issues behind that. There is a question here. I can repeat it since you don't have my.
Thanks. What are the limits for the number of replicas that you can have for a VM? Can I also have none? And what is the maximum number?
So first of all, as I mentioned, we specify number of failures to tolerate, right? And that we interpret into in number of replicas and appropriately generate all those dummy things, the witnesses I mentioned. So yes, you can say, I don't care about tolerating any failures, right? In that case, we're going to create just one replica. And now if you're unlucky and the host or the disk where that single replica resides dies, then you have lost your data. Now, how the maximum number of replicas you can have depends on the size of your host. So if you want to tolerate n numbers of failures, what we do is we create 2n plus 1 replicas. So, and the replicas, 2 replicas are never put on the same host. Therefore, you can do the calculations and you can find some of those things online in some of the blogs that some of my colleagues and I have written about how many replicas you can have. I believe in version 1 we support up to 3 host failures to tolerate. And there was a follow-up question, I think, from somewhere.
Hi. Yeah, if I start today with FSA, here.
Okay, all right, sorry.
Yeah. If I start today with FSA, is an upgrade in plan to vSAN?
I don't believe there are such specific plans of automated upgrade from VSA to vSAN, if that's the question, right?
Yeah.
So I believe those are considered to be 2 different products. And for example, as I said, vSAN supports any solution. So one can do a storage vMotion from any data store to vSAN, and from vSAN to any data store, as a matter of fact, but I, of course, expect people to do vMotion from other data stores to vSAN. So you can storage vMotion your VMs from any data store, including a VSA data store, to vSAN, if that is acceptable. Yes? Okay, we're out of time. Thank you.